Hello student, in this video I am going to explain how to write the units of physical quantity in terms of basic units. As you already know, the unit of mass is kg, unit of length is meter, unit of time is in second. But if you want to get the units of derived physical unit quantity, so how can you get it? This video will help you out. First one, I have written distance. Distance you already know, whenever there is a change in the position of a body, that is called distance. And if the change in position along one particular direction, then that is called displacement. But here we are not going to deal with the direction. So I am just writing here change in position. And when you express it in unit, so that will be meter. This is the SI unit. So distance, displacement, wavelength, all have the unit meter. Speed. Speed you already know, distance upon time. Unit of distance is meter, time unit is second, so it comes out to meter per second. Velocity. Velocity, displacement upon time. Just I told you, displacement unit is meter, time unit is second, therefore velocity unit is meter per second. If you express velocity or change in velocity, again the unit will be meter per second. If I write acceleration, acceleration is defined, formula is change in velocity upon time. Just I told you, change in velocity or velocity unit is meter per second, and this is second, and that comes out with meter per second square. Force. This is another physical quantity. You know that force equals to mass into acceleration. Unit of mass is kg, acceleration unit is meter per second square, and hence it can be expressed kilogram meter per second square. Pressure. Pressure is force upon area. Force unit is just I told you kilogram meter per second square, and this is meter square. 1 meter get cancel out, so you will get this thing, kilogram upon meter second square. Pressure gradient or pressure per unit length. It means pressure upon length. So kilogram meter second upon meter second square, the unit of pressure. Length unit is meter. It comes out to be kilogram upon meter square second square. Surface tension or force per unit length. Just I told you, force per unit length, unit of force kilogram meter per second square. Length unit is meter. 1 meter get cancel out, so you are left with kilogram per second square. Work. Work is defined as force into displacement, and just I told you force kilogram meter per second square, displacement is meter, and this meter gives you meter square, so it unit become kilogram meter square per second square. If write kinetic energy half mv square, mass unit is kg, velocity unit is meter per second, and whole square, again you will get kilogram meter square per second square. Power, work upon time. Work unit is kilogram meter square per second square. Time unit is second. Second square into second gives you second cube. The power unit comes out to be kilogram meter square per second cube. Now, frequency. Another physical quantity, it is expressed as number of revolution upon time taken. This is just a number, it has no unit. Time unit is second, so 1 upon second. So second inverse. Angular frequency or angular velocity. It can be written as angular velocity. And angular velocity is what? Angular displacement upon time. This angle unit is radian, time unit is second, radian per second. How I have written this unit? I have written this expression, just see to it. If I take a body is revolving in a circle, and in completing that one revolution it takes time t, And in completing one revolution, the angle completed is 360 degree. And in 360 degree is equal to 2 pi radian. So it is 2 pi by t. So in this manner, we have written this expression. What is impulse? Force into time. Just I told you kilogram meter per second square is the unit of force and time unit is second. 1 second get cancelled out. So you are left with kilogram meter per second. And this momentum, mass into velocity, mass unit is kilogram, velocity unit is meter per second, kilogram meter per second. So it means that they both have the same unit. So impulse and momentum have same units. Moment of inertia is mass into square of the distance kilogram meter square, because mass unit is kg and distance unit is meter, so kg meter square. Linear mass density. Mass per length, mass unit is kg, length unit is meter, so it is kilogram per meter. Angular wave number, it is 2 pi by lambda. 2 pi is an angle, this is unit is radian. Lambda is a wavelength, its unit is meter, so radian per meter. If you don't know the physical quantity of any other physical quantity, so you can determine that unit by using the suitable relation. Let us consider one example. F equals to gm1 m2 by r square. This is given by the Newton, universe according to Newton law of gravitation. G is universal gravitational constant. F is the gravitational force. M1 and M2 are the masses of two bodies and R is the separation between those two bodies. And I want to get the unit of G. So I have written G in at one point and the other physical quantity is being transposed to the other side. So G comes out to be Fr square upon M1 M2. Unit of F, you know that Newton. Unit of distance, you know that meter. Unit of mass, you know that kg. So it is Newton meter square per kg square. It is the SI unit. Now I want to write in the basic units. That's why in place of Newton, kg meter per second square. This is meter square. This is kg square. 1 kg get cancelled out. So you are left with meter into meter square meter cube kg second square. And hence we got this unit. So in this manner you can find out the units of different types of physical quantity. Thank you.